Namaste to all. I am Dr. Nikita Jain, Assistant Professor, Department of Mathematics, Mewar University. In this video, we discuss about the equation of curves in geometry. So, introduction to curve in geometry. So, first of all, definition of a curves. So, a curve is a continuous and smooth flowing line without sharp angle or breaks. In geometry, it refers to a shape that can be drawn on a plane or space. The curve is a open, closed, rough or smooth. Application of a curve in geometry is in design, architectures and engineering, modeling, motion in physics and computer graphics. Third, application represent real world phenomena like orbits and projectile motion. So we consider the some curves in geometry. First curve is straight line, and the equation of a straight line is y is equal to mx plus c. Here m is a slope of curve and c is a intercept on y-axis. Slope means, and this is a straight line, and slope means angle. This straight line angle with positive direction of x-axis, and c is the intercept. That means this line cut this point. This line cut y-axis is this point. So c is the this this distance is a c. That means intercept this straight line, intercept on y-axis. That means this is a c. Okay, so y is equal to mx plus c is a equation of a straight line. Here m is slope and c is intercept on y-axis. Next figure is circle. So equation of a circle in standard form is x square plus y square is equal to r square. Figure of a circle is this type of figure where center is 0 0 and this is a center and radius is r. Ellipse. So next equation of a ellipse is x square upon a square plus y square upon b square is equal to 1. Diagram of the ellipse is this oval shape diagram is known as a ellipse. Here two focus S and S dash are two focus and two directories. This is a two directories, and P is the any point on curve, and M is a point on directories. PM is a perpendicular distance on a point to directories. So curve eccentricity defined as P upon PM, where S is a focus, M is a point on directories. So any two-dimensional curve defined in eccentricity form as circle eccentricity is 0, always 0. Circle eccentricity is always 0. Okay, and ellipse eccentricity is always less than 1. And eccentricity means SP upon PM. SP means focus, S means focus. So and SP means distance of a focus from a focus to the point on curve, and PM means perpendicular distance of a point on curve at the point on curve to the point directories. So PM is the perpendicular distance from a point to the directories, and SP upon ratio of SP upon PM is eccentricity, and eccentricity less than 1, then we know this is the graph of ellipse. Yeah, this curve is ellipse. If eccentricity is 0, then we say this is a circle graph. Or A and B. So A is a vertex. This point is 0 0 because if x axis and y axis cut this point, so this point is 0 0. So A is this point, A comma 0, and A comma 0 point is known as vertex of the ellipse. A comma 0 is the vertex of a ellipse, and this point is minus A 0. So minus A 0 is the point of a vertex. Okay, and distance of O to this vertex is a and x square upon a square plus y square upon b square is equal to 1. Though that means is this x axis is a major axis on ellipse. Okay, and this y axis in a minor axis on ellipse. Okay, so standard equation of ellipse is x square upon a square plus y square upon b square is equal to 1. Next, parabola. Parabola equation is y square is equal to 4ax, and diagram of parabola is this type, where s is the focus and directrix always make by out back side of graph. So this is the focus, and this point is P, and directrix point is PM. So SP upon PM is eccentricity, and parabola eccentricity is always 1. Okay, parabola eccentricity is always 1, ellipse eccentricity is less than 1, and circle eccentricity is 0. And S is a focus, and P is any point on curve, and M is a point on directrix. Okay, and standard equation of a parabola is y square is equal to 4ax. A is a point on focus. A is a any point on focus. So focus point is here is coordinate of a focus is a0. Okay, clear parabola. Next figure is hyperbola. So hyperbola equation is x square upon a square minus y square upon b square is known as hyperbola. So hyperbola is figure of this type. So here also two focus S and S dash. S and S dash. Okay, so focus coordinate is AE comma 0 and minus AE comma 0. A is equal to this line. Origin to this point is distance is A. Origin to vertex. This is a vertex. So origin to vertex distance is known as A. And B is again this distance is B. So x square upon A square minus y square upon B square is equal to 1 is the equation of a parabola. Yes, curve in real life. Engineering and architecture's curve are used in the design of roads, bridge and building. Nature. Curve describe many shapes in nature like waves, trees, branches and the path of the planets. Computer graphics. Curves are used to design smooth transition, animation and 3D models. Application of a curves Application of a curves in business, data analysis and visualization, graphs and curve. So curve are essential in visualizing business data. For example, in area like sales, forecasting, profit margins and marketing trends. Curve like line graphs or supply demand curve are used to represent the relationship between two or more variables. Understanding the nature of these curves can help managers make informed decisions. Optimization and calculus applications, profit maximization and cost maximization. In economics, business often use mathematical optimization techniques to find the best outcomes. Curves such as the total cost curve or total revenue curve can to analyze how different level of production or investment affect cost or revenue. Derivative of this curve found through calculus can help determine the optimal point of production optimal points of production or price the maximum profit. Finance and investment analysis, risk return curves. In finance, risk return profits of investment portfolios can be represented by curve such as the efficient frontier in portfolio theory. These curves show the trade-off between risk and expected return, helping business and investors make informed investment decisions, market behavior and consumer preference. Indifference curves. So in microeconomics, indifference curves are used to represent combination of two goods that give the consumer equal satisfaction or utility. This help business understand consumer preference and make decision on product offering or pricing strategies. Next, conclusion. So curves are very useful in business. So conclusion of this curves are a fundamental concept in geometry that helps describe various shapes and motions. They are crucial for modeling natural and human-made objects, and their study is essential for understanding more complex geometric principles. Thanks.